Ever wish you could have a nice cold beer just perfectly poured? Well, your wish has come true. With our beer pouring machine, every beer is a perfect beer. Let's take a look at how it works. As you can see by this video, our design fulfills 5 main functions. It is initiated by the touch of a button, it lifts the cup into place, and then begins to lift the beer bottle until both are in the correct positions. Then the beer is poured from the bottle into the cup at the correct angle, and the now filled cup and empty bottle are lowered to their original positions. In addition, we have several secondary undesired functions that are addressed by this design. First, waterproofness. In case of spilling, the mechanism of the prototype had to be protected, and therefore a plexiglass cover and plastic guards are incorporated. Furthermore, a sturdy electrical box is used to muffle the noise of the motor and keep the user safe from the wiring. Lastly, our mechanism had to be time efficient. This was ensured by precise coding of the motors and numerous test runs. Now let's take a closer look at the mechanism behind the motion.
Here we'll look at the gear, motor, and chain mechanism isolated from the prototype to show how it actually works. On the left, we have the system that controls the motion of the cup, and on the right, the one that does the motion of the bottle. The cup begins to be lifted by the clockwise rotation of system A, and then the bottle motion starts a few seconds later with system B rotating counterclockwise. After 10 seconds, the cup motion pauses for a few seconds before changing rotation direction and lowering the cup back down. Meanwhile, the bottle is still lifting. It hits a maximum height, then gear B switches rotating direction and lowers the bottle back down as well.
So our critical function were all essentially met except for the detail that our motor turned out to be not powerful enough to power the mechanism and did not in fact have enough torque to move the mechanism. The rest was all tested and functioning properly. The previous video showed how our code to control the rotation and timing of the motor was correct. Our electrical wiring was done properly, and the assemblage of parts was successful. If we had enough time, we would have ordered new motor and tested them. According to additional calculations and minimum torque of 2.5 Newton times meter would be more than enough to power the mechanism.
We had 7 targets we strived to achieve for this prototype. The first was to successfully translate the energy from the power source to the mechanism. This was achieved through a pair of motors that rotated and initiated the motion of chain and gear systems. Next, we wanted to hit that perfect beer pouring angle, which, according to our research, meant the cup to go to 45-degree angle and the bottle about 15 degrees above the horizontal line. Though theoretically we would have succeeded in this, the insufficient motors prevented us from actually achieving it. In addition, the dimensions of our mechanism did allow for no spillage, as well as the foam thickness of under 5 cm, which was the goal. We wanted our prototype to be marketable and stylish, and deemed our final result acceptable, but could do with more improvements. Lastly, our prototype is stable. In terms of the main constraints, our finished prototype fit all of them. Its size allows it to fit easily on a counter, its weight allows it to be portable and moved, and its waterproofness makes it safe and user-friendly. In terms of cost, we finished under the budget. The biggest portions of the cost were allotted to the master parts, which included the gears, chain, and bearings. The rest was found at Rona, or we already owned.